ASP.NET Core Minimal APIs provide an alternative to using controllers and the MVC pattern. They are a lighter weight approach that can be configured completely inline within program.cs for very simple scenarios. You'll probably want to use a multi-file approach for any non-trivial application though. As you can see, the basic configuration of an endpoint between MVC controllers and minimal APIs is very similar. In each case, we need to specify the method or verb, in this case post, and the route, in this case payments, that is going to be used by this particular endpoint. After that, we have a way to accept a model, in this case a payment request, and then ultimately we'll do the work that needs to go inside the body of the endpoint. As we've discussed, controllers should typically return an action result of some kind. Minimal API style endpoints return iResult, and a new static class called result provides a large number of helpers you can use to return common result types, like no content, not found, etc. Minimal APIs work with Swagger and Swashbuckle, and you can add more information using annotations. The above code requires enabling annotations as part of adding SwaggerGen services, but once that is in place, your Swagger UI will display summary and description information as well as expected response types. When using minimal APIs, you'll still want to include good information in your Swagger documentation, which should include things listed here at a minimum. You want to make sure that you specify what responses your endpoint is going to support, as well as provide some summary and description information that goes along with the endpoint to describe the operation that is being performed. One challenge with minimal APIs that Microsoft hasn't provided much guidance on is how to organize them. Obviously, putting dozens of them in your program.cs file is a bad idea. Large files are more difficult to navigate and keep organized, are more difficult to work on concurrently with team members, and don't reveal as much about what was actually changed when viewed in source control, pull requests, or commits. There are other reasons why you should prefer using more than one file for your application that we don't have time to get into here, but it should be obvious that you should avoid keeping more than a few endpoints in program.cs, and instead put them into separate files. Having made the decision to organize your endpoints in files, this comes with the next obvious recommendation that you should use folders to organize them. The folders should typically correspond to the resource the endpoints manage. Ideally, each endpoint will be defined in its own file so that you can see everything that has to do with it in one place, without being distracted by other endpoints. I've used two approaches to this that I can recommend. The first is a package called minimalapi.endpoint, authored by my friend Cedric Michel, and another option is to use static extension methods. Let's see how we can organize minimal API endpoints using program.cs as well as the two alternative approaches. Minimal APIs are often shown in demos being configured completely inside of program.cs, which is also where the rest of the app is set up. This works fine for demo applications. Here you can see a typical program.cs for setting up minimal APIs. Once the app has been built and we are setting up the endpoints, you can see that we have two different endpoints configured here. The first is on line 53, where we map a very simple get endpoint to return a list of authors, and then on line 58, where we map a delete endpoint and add additional Swagger metadata so that we get some good documentation inside the Swagger document. Most real-world APIs are going to be much closer to the map delete option than the map get option, and in fact many will be longer still. It would not be unusual to have program.cs files over 1,000 lines long if a real application chose to try and put all of their APIs into this one file. So how can we break this up into individual files per endpoint? Well, the first version that I'm going to show you uses the minimalapi.endpoint library, and it is set up on line 47 by specifying to map endpoints. With this in place, any endpoints that are found that implement the iEndpoint interface will be mapped. For example, this author create endpoint implements iEndpoint of iResult, create author request, meaning that it will accept a create author request and return an iResult. To set up an iEndpoint, you need to implement two methods, addRoute and handleAsync. In addRoute, you perform the mapping to the appropriate HTTP verb, in this case a post, and configure what the variables are that will be passed in. These can include both the requested items as well as the dependencies that this handler needs. Next, inside of handleAsync, you do the actual work of the endpoint. In this case, we create a new instance of the author from the request, add it to the repository, and then create the response and return a results.created. Another way that you can do the same thing is through the use of extension methods. You can see an extension method on line 50 registering an author update endpoint. The extension method approach looks like this. Essentially, it just takes the entire map argument out of program.cs and puts it into its own method. If you had a great number of these, you could group them together so that you might have, instead of individual extension methods for each endpoint to use in program.cs, you could create an extension method of register author endpoints, for example, that would do a group of these. There's no reason why you couldn't do both, with the register author endpoints calling the register author update endpoint and register author create endpoint, etc. In any case, breaking up your endpoints into individual files is a best practice that will make them easier to manage, as well as easier to find and use inside of your source control. And when you look at an individual pull request or commit, it'll be obvious which endpoints were being addressed just by looking at the files that were touched. It's not unusual for web APIs to need to interact with asynchronous processes. While you can certainly use an external message bus or queue to communicate with another service, ASP.NET Core has built-in support for running background services as part of your API project. This can be a stopgap measure for many applications that don't require having multiple distributed services to support the level of load and complexity that they need. You can configure a hosted service in your web app by using the Add Hosted Service of T that is built in. You don't need to add any additional NuGet packages. Once you have set this up, you define the service as a type, typically inheriting from the background service base type. Then, you just need to override the execute async method and perform your work there or in another method that you call. Within execute async, you should specify a delay which will control the execution frequency. That is, how often the work that you're performing inside execute async is going to be called. Let's look at a quick demo showing how to set up and use background services in ASP.NET Core apps. Inside of program.cs, you can see that I have configured a hosted service which I'm calling a data consistency worker, as it's going to periodically check the database for inconsistent data and fix it up if it finds anything it knows how to fix. Now, because this is going to be working with the database, it's going to need to use a DB context or a repository, and in either of those cases, those are scoped services that I've already configured earlier on inside program.cs. In order to work with a scoped service, you need to add it with the scoped lifetime. And so you can see that I have a scoped processing service defined here, along with an associated interface, and I'm adding that on the next line as a scoped service. Now, looking at the background service itself, the data consistency worker, you can see that it is just taking in an iService provider. The reason it needs the iService provider is because the iService provider is going to manage the creation of a scope that will be used for the dependencies that we're using. So we don't actually request the dependency inside the background service because that background service is essentially a singleton. It's only created once when the application is started, and it will not get created again every time we execute it, right? It just lives for the life of the application. So in order for it to use scoped resources or services, it needs to create a scope itself as part of that execution. So inside of the do work method, you can see where we're taking the iService provider, which is in a property called services and creating our scope. And then inside of there, we're using that same service provider to get a required service, which is going to be the actual service that does the work, our iScoped processing service. The iScoped processing service interface defines just a single doWork method that returns a task because it's going to be async and accepts a stopping token so you can cancel it. The scoped processing service shown here implements the iScoped processing service interface and takes in a couple of dependencies, in this case a logger so we can see what it's doing, and the actual author repository which will be used to perform the work. The doWork method here is where all of the actual work is performed, as well as where I've decided to place the delay that will ensure that this doesn't run continuously on the application. So here all we're doing is fetching all of the authors that have an invalid Twitter alias, meaning that it doesn't start with an @. Then, once we've found any, we update them by prefixing them with an @ symbol. And then, after that's been performed, aside from doing some logging, we're done, and we delay for 30 seconds before checking again. This is just a trivial example of how you could use a hosted service. There are, of course, many other things that you could do with them. Common operations include any sort of I/O that can be performed out of process, such as uploading files, sending emails, working with cloud resources, etc. Keep in mind hosted services and background services as another best practice that you can use to make sure that your API endpoints are not trying to do too much in the scope of the endpoint call itself, instead of delegating things to a background service that can do the work without delaying the returning of the user's request. In this module, we covered a lot of ground in terms of best practices for implementing web APIs with ASP.NET Core. We started with MVC and a bunch of tips and features, as well as best practices related to using MVC for your web APIs. Then, we introduced Mediator as a way to keep controllers smaller and encapsulate the logic for each endpoint in its own handler. We jumped from this idea to the Reaper design pattern and the API endpoints NuGet package, which does a similar thing with fewer abstractions and files. Then we shifted gears and took a look at some best practices for working with and organizing endpoints defined using the minimal API approach. Finally, we wrapped up by showing how to perform background tasks in your app with support for scoped dependencies. Up next, we'll look at a few best practices for securing your web APIs. Hope to see you there. Welcome. I am, as always, Steve Smith, aka rDallas, and in this module on Web API Best Practices, we're going to focus on the very important topic of security and how to keep your APIs and the data they carry secure. In this module, we are going to review security best practices for web APIs, starting with the most common approach of JSON Web Tokens, or JWTs, with ASP.NET Core. Then, we'll spend a little bit of time describing how to use these tokens properly, and then look at some alternatives to using tokens for securing APIs. We'll review some best practices for implementing authorization and authentication in ASP.NET Core for web APIs, and we'll wrap up by configuring CORS and HTTPS for our ASP.NET Core based web API applications. Let's get started.